Team, it's Mr. Z, and today we're going to look at everyone's favorite part of the unit, word problems. Let's go ahead and dive on in. All right, so our goal in this task is to write an equation to model each scenario and then solve each equation. So go ahead, take a moment, pause it, read through this word problem. I don't need to do the reading for you, but we're going to go ahead and annotate it together. All right, after reading to it, basically you can see that Melissa takes her 50 hours a week to service all of her customers. So it takes Melissa by herself, one person, it takes her 50 hours in a week. Now, she's going to hire a second person, Kaylee, and Kaylee by herself is able to work in 60 hours. So Kaylee by herself is able to complete the task, the one task in its entirety, in 60 hours. If she works together, how long will they be able to complete the task? Serve all of their customers in an unknown number of hours. My biggest clue to you is we're studying rational functions, aka fractions. So there should definitely be a fraction in the equation that you create. So when we're looking at this, our domain restriction is going to be when the denominator is 0 and x cannot be 0 in this instance. So let's go ahead and solve by multiplying by the LCM. So my first step in solving this guy is I'm going to extend my denominators. 1 plus 50 over 1 over 60 is equal to 1 over x. I'm going to go ahead and multiply by my denominator 50 first. So I'm going to multiply 50 to the left side and to the right side. Now I'm going to cancel. I see 50 divided by 50 is going to divide out evenly. Now 50 and 60 don't divide evenly, but I see an opportunity to reduce the fraction. 50 over 60 is the same thing as saying 5 over 6. Doing this now will help clean up the numbers to make sure that they're small and approachable. So I'm going to go ahead and clean this up, and I get 1 plus 5 over 6 equals 50 over x. I'm going to go ahead, extend my denominator or my fraction bar, and now I'm going to multiply by 6. I do it to the left side, I do it to the right side, and then I cancel. So I'm going to go ahead and rewrite this over here. And 6 times 1 is going to result in 6 plus 5 equals 50 times 6. I'm going to ask myself, what is 5 times 6? And that's going to be 300 over x. I see an opportunity to combine like terms. I know that 6 and 5 together is going to make 11 equals 300 over x. And to get rid of this denominator, I'm going to multiply both sides by x. It's going to cancel, and I'm going to be left with 11x equals 300. And using inverse operations, I can divide each side by 11, producing my final answer, 300 divided by 11. Now, to provide a little more context, because we're going to be using hours, you can feel free to use a calculator to do 300 divided by 11, and that's going to end up giving you 27.27, repeating, which is a fancy way for saying 27 hours, and then it's going to be 27 over 99. Now, the reason it's over 99 is because it's a repeated fraction. This right here will give you full credit by explaining the domain restriction and the number of hours. However, if you wanted to reach for the stars and get a 5, I would go ahead and reduce this fraction by dividing by 9. That's going to be 3 over 11. And then you can go ahead and change that to be out of 60. 3 over 11, if I estimate it, is roughly the same thing as 3/10. And I can rewrite this to be 27 hours. And I'm going to multiply it by 6 to get 18 minutes. This is an estimation, so it's a little bit over. I couldn't just go ahead and say 27 minutes because decimals are out of 100 and hours is out of 60. I had to essentially take 3/10 and figure out, hey, I'm going to multiply this by 6 and 6. And that's how I got the 18. All right, take a moment, breathe it in. We're going to go ahead and move on to the next one. Again, pause, take a moment, read the word problem for yourself, and then when you're ready, unpause. So, Edward can complete a 4-foot by 6-foot quilt in 16 days, while Juan can complete the same task in 12 days. So there's these extra numbers, but basically they're saying that they can complete one quilt in 16 days. Edward can complete one quilt in 16 days, while Juan can complete the same task in 12 days. How much time will they work together? How many quilts are they completing? Oh, I forgot about Nancy. If they solicit Nancy's help, she can complete it in 14 days by herself. So 1 over 14. So you can see where I get each piece of information is from a separate bit. They are completing one quilt, and they're just simply asking how many days. One quilt in 16 days, one quilt in 12 days, one quilt in 14 days, and how long would it together to complete a quilt? So I have it set up. Now I'm going to go ahead and start eliminating my denominators. I'm going to go ahead and see 16, 12, and 14. And I'm going to go ahead and start out by multiplying by the denominator of 16. So I write it out. I'm going to multiply each part by 16. And then 16 divided by 16 is going to cancel, leaving me with 1. Now I am going to take an opportunity to reduce. I see 16 over 12. Both of them are even, meaning both of them are divisible by 2. I'm going to take half of 16, which is 8, and half of 12, which is 6. I see that both of them are even, therefore they are divisible by 2. So I'm going to repeat the process. Half of 8 is going to be 4. Half of 6 is going to be 3. So I can reduce this fraction to be 4/3 plus 16 over 14. I'm going to reduce. I know that 16 is going to be divisible by 2, and 14 is divisible by 2, leaving me with 8/7. Notice I did multiply the numerators. 1 times 16 is just 16. So I can essentially just ignore that 1 after multiplying. This is going to lead me to a sum of 16 over x. Now I'm going to decide to multiply by 3 to each term. 3 times 1 is going to result in 3. 3 divided by 3 is going to cancel, leaving me with just 4. 8 times 3 is going to result in 24 over 7, which is going to be equal to 16 times 3. To do it mentally, I'm going to do 3 times 10, which is 30. 3 times 6 is 18. and I'm going to take the sum of those. So I have 30 and 18. I'm going to slam them together, and I'm going to get 48 over x. You can see how my denominators are slowly disappearing. I'm going to take the opportunity to combine 3 and 4, and I'm going to have 7 plus 24 over 7 is equal to 48 over x. I'm going to go ahead and now multiply each piece by 7. 7 here, here, and here. I see that this is going to cancel, leaving me with 7 times 7 is going to result in 49 plus 24 is going to be equal to 48 times 7. 48 times 7 is going to produce 336. Don't be afraid to use some scratch work. You can always do 48 times 7 on the side of your paper. My final thing, I see an opportunity to combine like terms. So I'm going to add 49 and I'm going to add 24. That's going to produce 73 is equal to 336 over x. I'm almost at the finish line. I'm going to multiply both sides by x in order to eliminate the denominators. And I get 73x, which is going to be equal to 336. Using inverse operations, I can divide by 73. And I'm going to end up to be getting 336 divided by 73, which is 4.6. So essentially, how long will it take them to complete a 4 by 6 foot quilt? 4.6 hours. Now, 4.6 hours, this 0.6 doesn't mean how many minutes. If I wanted to go advanced, I could remember that 0.6 is going to be the same thing as 4 6/10. To make that out of 60, I'm going to multiply the numerator. So essentially, this would be 4 hours and then 36 minutes. Remember, this is just the extra bit. I will be very happy with 4.6. All right, one more to go. All right, take a moment, pause, and read through the word problem. Unpause when you're ready. Seeing through it, you can see Daniel can decorate 8 dozen cookies in 90 minutes. Abner, on the other hand, he needs 120 minutes to make 8 dozen cookies. They work together. How long does it take him to decorate 16 cookies? So looking at it, you're like, oh, Daniel does 8 in 90 minutes. Abner, well, he does 8 in 120 minutes. And then together, how long does it take him to decorate 16 cookies? So this is a little different. Notice how the numerators vary. This 16 dozen cookies. Now, when you see numbers that can be reduced, depending on your vision and your perception, you can preemptively reduce some of these fractions to make the numbers smaller. For example, both of the fractions on the left, I see an even over an even, so I'm going to divide them both by 2. I'm going to get 4 over 45 plus 4 over 60 equals 16 over x. And I'm going to reduce again. 4 over 45 is as good as it's going to get, but this is going to become 2 over 30 equals 16 over x. And I can reduce it one more time to get 1 over 15. All I'm doing is just repeatedly dividing by 2 on that middle term. They are equivalent fractions. This is completely legal. Now, what I'm going to do is get rid of my denominators. I'm going to multiply each side by 45. Let's take a look at what happens. So I extend my numerators. 45 plus 1 over 15 is going to be 16 over a number. I multiply each bit by 45, 45, and 45. Cancels. Now 45 over 15, you can see that they're both divisible by 5. So I'm going to divide it by 5. That's going to be 9. 15 divided by 5 is 3. And then I'm going to go ahead and have 4 plus 9/3 is equal to 16 times 45 over x. Now notice how 9 divided by 3, I can just simply solve that to get 3. And then 16 times 45 is going to result in a product of 720 over x. 4 plus 3 is 7, which is equal to 720 over x. To get rid of the last denominator, I'm going to multiply the left and the right side by x. You're going to notice a cancel. I'm going to have 7x equals 720, leaving my last step to do inverse operations, dividing by 7. And then this is going to result in x is equal to 720 divided by 7, which is 102.85 hours. Now, I ended there. It goes 857. I can technically round up if I want to get 86. You can be done here. However, if you wanted a more accurate picture, this is in hours, and you have to remember the decimal is just a fraction. 102 and 86 out of 100. Think about it like money. 86 cents out of a total of 100. And I'm going to go ahead and need to convert this denominator. I'm going to first reduce this as well as I can. I see half of 86 is going to be 43 over 50. Now I'm going to kind of estimate here. I'm going to see that 43 is pretty close to 40 over 50. And I'm going to cancel that to be 4 over 5. So essentially, I have an estimated answer of 4 over 5. How many 5s are in 60 is 12. And then I'm going to end up with 102 hours and then approximately 48 minutes. This answer is an estimation. Whenever you kind of change the fraction, you know that it's not going to be exact, but this gives you a closer estimate. The reason I am exposing you to this is just to help differentiate that decimals don't always convert nicely into time. So if you need to end here, that is fine with me.